Hello. Yeah. Just to confirm, I'm audible, right? Can anybody confirm?
Yes,
Yes,
sir.
yes.
So, yeah, welcome to the second session on digital circuits. Uh, NPTEL might have provided you the previous session video. Uh, I will share the link of the previous video or the YouTube channel, okay, at the end of the session. Don't worry. Okay, so yeah, so I'm Kailash, PhD scholar at NODC Lab at IIT Gandhinagar. So today we'll be discussing some of the questions on the digital circuit, the second session, and whatever you've been taught in the second week, right, which will be helpful in submitting the second assignment also and the third assignment. Uh, So let's move to the course layout. In the today's session, we'll be discussing mainly about the number system and the Boolean algebra. Also, we'll be discussing some of the questions on K-map. So, okay. So the very first thing which we'll be discussing today, and the question on the basis of IEEE 754 number representation. Okay, so the IEEE 754 number representation is one of the standards which is accepted in the entire industry. In all your system actually follows IEEE 754 number representation. So how do you represent IEEE 754 number representation in the single precision? So the very first thing is in the single precision we only have 32 bits. Okay, so this is actually already been discussed by the instructor in the video session in the lecture. But I'm just revising you again such that we can attempt the questions on the basis of that. Okay, so if any number has to be represented, it has to be represented in the form of 32 bits, and the 32 bits, out of this 32 bit, the first bit will represent the sign of the number, right? If a number is negative, then the sign value will be 1, so sign is equal to 1 for a negative number, right? If for a negative number, okay, and it is equal to 0 for positive number. So this everybody know. Okay, then we have what we call as exponent, right? So exponent represent a number which is actually denoted by e. And how do you represent a number in the form of IEEE 754 is you require this e. Along with that, you require another component that is called mantissa, right? So mantissa is something which is the floating point part of your number. So any number can be represented like -1 to the power s multiplied by 2 to the power exponential minus 127, right? So this 127 is what we call as bias of 32-bit precision number, and this will be multiplied by 1 dot mantissa. Okay, please note that this one is hidden. Okay, so this is not been actually stored. However, this will be actually used while you will be doing the computation. And please note that IEEE 754 number representation we are actually using from long back from 50 years, right? And still it is prevalent. So it is extremely necessary to understand this number system, right? And we should know how to represent a number in IEEE 754 number representation. Here IEEE 754 actually represent the standard, right? So if you will open the documentation of IEEE, if you go to the 754 standard, you will find the details of this particular number representation. Okay, so in other words, we also call this as a floating point number representation. Okay, so for you, if you want to understand, right? So now moving to the first question which we'll be discussing in the today's lecture is this one, right, where I have given a number -14.25, and what you have to do is you have to convert into the IEEE 754 representation. Okay, so whenever I talk about IEEE 754 representation, I have to convert this number into something like this: -1 to the power s into 2 to the power e minus 27, 127, right, into 1.1 okay. So and this has to be converted into binary, right? So how to approach this number is what we'll be discussing, how to approach this conversion, what we'll be discussing in today's class, right? So the very first thing is the sign, okay. So you can easily see here that the number is a negative number because I have represented here at minus 14.25. Please note that this is a decimal representation, right? So we know that if it is a sign representation, that the sign bit will be 1 for a negative number, right? So that is very easy. Okay, now we need to find out our exponent and what we call as our mantissa. Okay, so to find out exponent, what we have to do is we have to find out this e. Okay, but before that, let us convert this number into binary first. Okay, so let us first convert this number into binary first. Can anybody tell me what is the binary representation of 14?
1110.
So 1110. Okay. And anybody tell me what will be the binary representation of 0.25? Anyone?
0.01.
101. You're saying like this? Is it what you're saying?
0.01.
Okay, 0.01. Okay, that's correct, right? So if you don't know how you convert a decimal number into binary, it's very easy. What you have to do, you have to use write the number, you multiply it with 2. Okay, so we'll get 0.5, right? So this is your first digit, and then you just keep on doing that. Okay, you just write the 0.5 into 2, right? So this will be so you have to keep on doing that until you get 1 here. Okay, so now you get 1.0, so it is 0 and 1, right? It is 0 1, so it will be 0 1. Okay, so the number which we have here is 1110.01. Okay, so now if we write in this particular form 1 dot mantissa, what we have to do, we have to shift the decimal. So what we can do is we can write 1.11001, right, into 2 to the power 3. Okay, so this will be the representation in binary format, right? We still have to represent this number into the format. So let's see what will be the value of the exponent which we have here, right? So the value of exponent will be calculated using this, right? So you know here it is 3, and the value it should be is e minus 27, e minus 127, right? So by just looking, or by just looking into the analogy, it will be e minus 127 is equal to 3, right? So e is equal to 130. Okay, so we got the exponent value, right? So what we have to do is we have to convert this 130 into the binary to solve this particular problem, right? So let me convert this e into 130, right? So the exponent will be e will be 1, right, followed by 1 2 3 4 5 zeros, then 6, then 1, right? So this is the decimal representation of exponent, right? The only thing which we are left is with the mantissa, right? And we have already calculated that the mantissa is 11101, right? So the m is 11001, right? Please note that you have to ignore this particular one. Okay, and it will be followed by all zeros. Okay, it will be followed by all zeros because you have to represent 23 bit. Okay, you have to represent 23 bit, so it will be followed by all zero. Let us see which of the option is we can see here which of the option is answered. So if you see, the first option is what we are getting here, right? So 1, then 1 5 times 0 1 0, right? And 1 1 0 0 1 followed by all zero. Okay, so this is how you convert a binary number, or sorry, a decimal number into a floating point representation. Okay. Anybody has any kind of doubt in this particular question, or how we convert decimal number into a floating point representation, a single precision floating point representation? Anybody has any doubt in this particular part? Did you understood? You can respond in the chat also if you have understood.
Sir, can you please repeat Mantissa? How did you get Mantissa?
Okay, how did I get this particular part? Okay.
Yes, sir.
Yeah, sure. Okay, so let me just repeat for you again, and those who have listened, that is fine. If you have not understood this part, yeah. So I will just repeat for you again. Okay. So we got the decimal representation of 14 is 1110, right? And then the decimal representation of 0.25, 0.25 is what we call as you have to how you have to do is you have to multiply it with 2, right? You will get 0.5, then you multiply it with 2 again, right? You will get 1.0, right? So this will be 0 1. Okay, so 0 from here, 1 from here. Okay, now what I have done here is I've just written this into this format. Okay, so if I want to write into this format, I want 1 dot m. Okay, so 1 dot, if I will shift it here, right, the decimal is shifted from three places, right? One, one, zero, zero, and 1. Okay, so I have to write here 2 to the power 3. Please note that it's not 10 to the power 3, it will be 2 to the power 3. Why? Because we are talking about the binary number system, right? And this part is what we call as Mantissa. Is it clear?
Yes, sir.
Other students, any other doubt?
No, sir. Everything is clear.
Everything is okay. So let's. If everything is clear, then the next question is for you. Okay. So here it's the same question, right? And just the trick is you have to just convert it into hexadecimal, right? Anybody wants to attempt with me, right? So you can try it out on your own. It's the same different number, minus 40.1. And what you have to do, you have to just show me how does it will look into hexadecimal. Okay, so in hexadecimal, it is of 32 bit, right? You know that each of the bit will represent 4 bits, right? So I have 8 bit, 8 numbers, right? So it will represent 32 bit, right? You can convert it into binary, but how will we attempt is we will just convert this number into IEEE 754, and then we will convert into hexadecimal. Okay, so again the sign bit will be remain 1, right? So sign bit will be 1. Then we have two things, right? So here we have 40 and then zero point 0.1, right? So how to proceed with this? Okay, so what I've said is what you have to do to convert a negative a decimal number, right, which is after decimal, into binary. What you have to do, you have to multiply with 2, right? So zero point 0.1 into 2, this is equal to zero point 0.2, right? So you will get like this. Then zero point 0.2 into 2, this will be equal to 0.4, right? Then 0.4 into 2, right? This will be equal to 0.8. Then 0.8 into 2, this will be equal to 1.6. Okay. And then if you will keep doing that, zero point 0.6 into 2, this will be equal to 1.2, right? You will you'll get the number, right? So you'll keep getting the number. Let's try one more. Okay, zero point 0.2 into uh, 2, this will be again 0.4, right? Then 0.4 into 2, right? This will be uh, yeah, 0.8, like this, right? So what number we are getting here is 000, then 1 1. Okay, and then it will be followed by yeah, currently it will be followed by 0, right? We will see that. Okay, so this is the number we are getting for the Mentisa. It will be, the pattern will be continued, right? But what we have to do, we have to find out one of the option. I think this much information will be sufficient for us. Okay, and then the decimal representation of 40. Anybody want to give me the decimal representation of 40 into the binary? Anyone? One.
So 101 000.
101 triple zero. Okay, so this is 8 and this is 32, so it will be 40, right? It is correct. So what do we have here is 101 000 dot 0001100, like this. Okay, so yeah, So if you want to find out the exponent out of it, right? So what we have to do here is again, what we can do, we can shift this number to the extreme left, right? What you can do is you can write 1.010000, right? Then again 000, and then 1100 into 2 to the power 5. Okay, so because we have shifted 5 bits. Okay, so you can write like that, and similarly the exponent will be uh, exponent minus 127 will be 2 to the sorry, will be 5, and exponent will be 132. Okay, so please repeat the first step. Okay, so you're talking about this particular how I have converted this into the decimal part into the binary. You're saying that? Hello.
This.
So it's simple, right? So what you have to do, you have to just keep on multiplying with 2. Okay, so you what you do, you write 0.1 into 2, this will be 0.2, then 0.2 into 4, it will be point, sorry, 0.2 into 2, it will be 0.4, 0.4 into 2 equal to 0.8, right? Then 0.8 equal into 2, this will be 1.6, right? Then zero point 0.6, you have to take zero point 0.6 from here, then again into 2, 1.2, right? And you have to keep doing that, right? So when you get two ones, right, you just stop there. Okay, so you don't need to proceed, you just stop there. So what you will get is you will get 00011, then you get similar kind of pattern. Okay, so and then what we have done, we have written the first part, right, the integer part and the decimal part here, and then we have calculated the exponent. Okay, so let's see what the exponent value we will get, right? So the exponent we will get is 1, right? 1 2 3 4, then we will get 100, right? So this is 128, and then this will be for 132, right? This is correct. Okay, and then if I see the mantissa part, right, so this will be 0 1, then 000, right, and then again 3 zeros. Okay, then 1 1, then 0 0, right? It will just keep on doing that. So up to this it is clear. Then I will, what I will do, I will convert this into hexadecimal. If there is any doubt, yeah, please ask. I believe there is no doubts, so I am proceeding ahead. Okay, so I am just removing it. Okay, so I will write this number 1, that's my sign. Okay, 1 is my sign, then followed by exponent 10000, then 1, then again 2 zeros. Okay, then followed by my mantissa pattern 0 1 1 2 3 4 5 6 1 1 0 0, right? Let's see if I have not done any mistake. We will get the correct answer. So we have to convert this into hexadecimal, right? So this is my C. Okay, then this is my 2, right? So all the options are correct there. Okay, then again this is my 2. Okay, so we are left with first option and last option. Okay, and then what do we have is 0. Okay, and then you have 6. Okay, so if you see here, right, so C2206, right, so C2206, and then I think we need so this option also correct, or and this option is also correct, right? So what we have to do is we have to further proceed with proceed ahead, okay, to generate more numbers. So it will be 00, then again we will have 1, right, and then we have 1, then again 0, right? So you have you this pattern will keep on repeating. Okay, so again 6, right? So this option is correct, fourth option. Is that clear, everybody? Is that clear?
Yes, sir. Sir, I have a doubt how to convert binary IEEE to decimal.
The other way around.
Yeah. Question number 14 from assignment number 2.
question number 14. Okay, so then I have to open the assignment. But yeah, that's fine, right? So just 1 minute. So just remind me the question at the end of this. So I will just cover all the question which I have, and then I will take your question. Is that fine?
Okay, sir. Yeah, yeah, yeah. Thank you.
Sure. So yeah, we are done with this part. Okay, and then what we will do is we will move ahead. Right? It's a very simple question. The Boolean expression AB plus AC bar plus BC can be simplified to. Anybody want to give the answer?
AB plus AC bar. Number
AB
3.
plus, you're saying third option?
Yeah.
Third option. Anybody else?
I hope it is consensus theorem, right?
Sorry.
It is consensus theorem, I think.
So you give me the answer, right? So, hello.
Sir?
You are also sticking with the three?
Yeah.
Okay. Anybody else? No one? Okay. So instead of applying a theorem, right, we will just what we will do is we will make the Carnot map, right, to just solve this question, and we will see, right, how we can go. Okay, so that's a very complex way to approach this kind of question. Okay, but let me try this approach. Right, why it is complex? I will be saying that, and I will be discussing if time permits the second approach also. Why? Because instead of writing AB, because you cannot fit AB here, right? Because A, this is BC, right? So this will be 0 0 0 1 1 1 and 1 0. Okay, so this will be B bar C bar, right? B bar C, then BC, then BC bar. Okay, so if I want to write AB, so AB will be ABC plus ABC bar, right? Yeah, because I just want to take this opportunity on this question to revise many of the concepts. Okay, so is this fine with you, everybody? What I have written? Hello, I can write, right, AB like this.
Yes, sir.
Okay, right. Other students also fine, right? Only Vivek is responding. What about the other students?
Yes, sir.
Okay. So see, similarly, AC can be written, AC bar can be written as, right, A B C bar, okay, plus A B bar C bar. Okay, so I have two more terms, right, and then we will be having A B C plus A, then yeah, A bar B C, right? This is correct. Okay, so I have two ABC. Okay, so when I will go to 0 1, right, so let me put down this 2. Okay, so this will be 1 1 1, so I will put here for these two. Let me just take another color for this one and this one. Okay, so there is one here. Okay, now what I have is ABC bar and ABC bar. Okay, so this is 1 1 0. Okay, so 1, then 1 0. So 1 I have here, right? Just correct me if I'm wrong anywhere, any place. Then what I have is a uh, B bar C bar, right? 1 is followed by two zeros, so 1 followed by two zeros, so I have 1 here. Okay, and then what I have is A bar BC. Okay, A bar BC, so this will be 0 followed by 1, right? So 0 followed by 1 1. Okay, so now it is extremely simple. Okay, so you see here I can combine these two. Okay, and then what I can do, I can combine these two, right? So I will only have two literals. Okay, let's see what do I have, right? The first is what we have is BC, right, and plus here what I have A, and then what do we have common here? C bar, right? So this is BC plus AC bar. This is a wrong option. Is that clear with everybody?
Yes,
Yes,
sir.
sir.
Right? What
One
has been
second.
done? Yeah. Anything?
Repeat it once again.
Sorry. Should I repeat?
Once again.
Okay. Should I repeat once again the entire thing?
Yes.
Okay. Okay. I will do that. Okay. See, let me just remove it and I will do it. Okay, for you.
Sir, can you solve by algebraic method?
Yeah. Why not? Let me first go through the Carnot map, right? And I will go through the algebraic one also. Okay. This is my A. This is my BC. Okay. And this is my 0 0 0 1 1 1 and 1 0 then 0 and 1, right? How I have converted this will be my ABC, then ABC bar. Okay. Then what I will have ABC bar. Okay. Then what I will have here is ABC bar and AB bar C bar. Okay. Then I will have ABC. Okay. And then what I will have A bar B C. Okay. So for this, okay, let me change color. What I have done, I have just converted into three literals, right? So I can do that C plus C bar, because if you will combine these two, C plus C bar will be 1 and I will be left with AB. Okay, so you have to add everything. So I've just converted this into this literal, and so sorry, right? So if you see this one and this one, both are same, right? So I can write 1 1 1 here, right? Because this is 1 1 1, right? This is 1 1 0. And do I have any other? Yes, I have 1 1 0 here. Okay, so if I will combine these two, what I will get here is 1 1 0, this one. Okay. And if you will see here, this is 1 0 0, so this is 1 0 0. And if you see 0 1 1, okay, so 0 1 1, this one. Okay, so if I will combine this, what I can do here is I can combine these two, right, and this two. Okay, right, you can combine this also, but that will be an extra term. Okay, so if you will combine this will be an extra term, right? And that is what is given into the question, because in the question what is being done is, if you will see here, they have combined this also. Okay, you see, they have combined this also, and if you combine this, what you will get here, it is B. No, I think they have not combined this. Just 1 minute, right? So here, yeah, A and B, right? So here they have combined this also. It will you will get AB, right? So which is an unnecessary term. Okay, so let me just remove it. Let me just remove it and just so if you will combine these two, it will you will get A, and from here you will get C bar, right? And then from here you will get BC. Okay, so A C bar plus BC. So it is being reduced to this particular part. Is that clear? Whoever asked this question. Anybody wants to give me an idea, if I have to attempt this with algebraic method, how will I do? Anybody wants to try? One of the students has asked that can I do with the algebraic method? Anybody wants to give me an idea? Hello, if am I audible?
I think we can include this.
Yes, sir.
Yes, so what we should do,
We can include C in the first term.
we can include C in the first step.
Yeah.
Okay, what you are saying is, okay, yes, so you will get ABC plus ABC bar. You are saying like this, plus AC bar plus BC.
Yeah, yeah. Like
Okay,
this.
then what should I do? So then
And
what you
combining
can
the
do,
first and last term,
yeah, combine this
first and
first and
last
last
term,
term, right? So this will be
and
BC
second
bar.
and third term.
Yeah. Excellent, right? This will be BC1 plus A, right? So this will be BC, okay? And then if you will combine these two, this will be AC bar, right? 1 plus B, right? This will be AC bar, right? So this will be BC plus AC bar. Is it clear, everybody? I think this was an easy idea. So that is the reason why I've said that whatever the approach I am approaching, right, that's not a good idea. But to understand the concept, right, so it is necessary. So we have two approaches to solve the same problem. I hope you are clear with both the approaches. Should I proceed?
Yes, please.
Okay, thank you. Let's move to a very simple question. Anybody wants to answer this? What it will be? It's a gate, right? Written in a very complex manner. Right? As a designer, I won't do that. But this is just a question for you to understand what gate it will represent.
NAND gate.
Sorry,
NAND gate.
NAND. Okay, I got an answer that
It's
it will
NAND.
be.
It's NAND.
It's NAND. Okay, two answers of NAND. Others, please want to write in the chat. I want to see that. Okay, what are you thinking? Two people have said that it's a NAND gate. What about others? Please write in chat whatever you feel.
Sir, and gate. Third.
And okay, somebody has said that it is an AND gate. What about other people? If you can just comment on the chat, right? That's fine. I won't judge you. Yeah, don't worry. You should answer, right? So, in that manner, the concepts will be clear. From Mohammed, I have seen it's NAND. This session is to make sure that you understand whatever that has been taught in class, right? So let's see what it will be, right? So I don't know what gate it is. Okay, let's start and let's understand what gate it will be. So you see, it's a NOR gate, right? It's a NOR gate, right? And when you combine both the input of a NOR gate, what it will become? It becomes a NOT gate, right? So the output will be here A bar and it will be B bar here. Any doubts in this particular aspect? Ankita has said that okay, it's an OR gate. We will see now. We have a couple of answer and OR. NAND is majority here. Any question? Okay, so it's simple, right? If you combine both the input of your NAND gate or NOR gate, it will be a NOT gate, right? If you don't know how it is, it's very simple. What you do, you just write a truth table, right? A, B, and then you write Y. Okay, then 0 0 0 1 1 0 1 1, right? When you combine both the inputs, okay, sorry, yeah, when you combine both the inputs of a NAND gate, so this is my NAND gate, right? So both the inputs when combined, it means this condition I am talking about. So if I am providing 0, it will give me 1. If I am providing 1, it will give me 0, right? So it's an A bar, B bar. So this is what I've said for NAND gate. Let me just tell you for NOR gate also. Okay, just in case if you don't know. If you know, it is perfectly fine. 1 1, right? So what is the opposite of NOR gate? It will be like this, right? And if I combine both the input, so I will come up with these two pattern, right? Either I can provide 0 or 1, right? Again, it will be an inverter. Okay, so A bar B bar. Then what you have done, you have passed A bar B bar, so A bar plus B bar, right, to whole bar. Okay, and then what you have done, after that, what you have done, you have again provided an inverter, right? It means followed by one more bar. Okay, so you can cancel both the bars and you will have A bar plus B bar, right? And if you apply theorem, it will be A dot B bar. Okay, so it's a NAND gate. Other students, it's clear why it is a NAND gate. Here it will be A bar plus B bar to whole bar, right? And then here it will be A bar plus B bar to whole bar to be whole bar, right? So I have discarded this and just combined this. So this represents the NAND gate. Okay. Now let's move to another question. Okay. So I have a Boolean function, okay, of three variables, and can anybody tell me what expression it will give me? Right. I want to give you 2 minutes, and just write your answer in the chat box. I will also do along with you. Nand Kishore Thakur. I will repeat the question for. Don't worry. Right. Just go through this question. After this question, I will repeat the question for again. So yeah, this will be my 0. This is 1, 0, 1, 1, 3. This is 2, right? 1, 0, 0, 4, then 5, then 7, 6. Okay. So I have 1, then I have 2, and then I have 5, 6, and 7. Yeah. So now what we have to do is we have to combine all of this. Okay. Anyone? Did you got the answer? Anybody?
Yeah, that is B XRC plus AC or AB.
Sorry. Can you repeat again?
B XRC plus AB or EC.
Sorry, I couldn't hear. There is a lot of noise. Can you type uh, with a knot like that?
Okay,
Here.
B XRC.
Huh?
Could you hear me?
Sorry. B. What you're saying? B.
B XRC
B XOR C. Okay. B XOR C
plus AB or AC, anyone.
plus AB, or you can write also AC also. It's like that.
Yeah, yeah.
Okay. Okay. So let me try. Let me see. Right. What it is. Okay. So if you will combine it, this part. Sorry. I will just write like this. If you combine this also, what you can do is you can combine this also, right? And you have two option of combining now, right? So you can combine either this or this. Okay. So if you see, if you combine this will be y bar z, and this will be y z bar, right? So in his case it is b sorry, b bar c plus b c bar. Okay. And then what you can do, you combine these two. So I will combine these two, and this will be yz, right? So this will be sorry, not yz, this will be x and x and y. So this will be x and y. In his case it will be a and b, right? So this is b XOR c plus ab. In my case it will be y XOR z, right, plus xy. So that's correct answer. So everybody is getting the same answer. Everyone, just drop a text in chat that okay, you're getting the answer. Yes, that will be fine for me. Okay, thank you, Diksha. About what about others? Manjunath. Okay. Yeah. Other students. Okay. So there was a question on the previous slide uh, that okay, how you have done this part, right? So this is what we call. Anybody know which theorem it is?
De Morgan's theorem.
Right. So it is the famously known as De Morgan's theorem. Okay? De Morgan's theorem. Okay. So you can split. You can write uh, AB bar, right? Like A bar plus B bar, like that, right? If you don't trust me, okay, what I will do for you is I will just prove this particular aspect. Okay, I have some time, so I can prove it. Okay, so I will write a truth table for AB bar, right? So that's my NAND. So you everybody know, right? What is the truth table of NAND, right? So this will be 1110. Okay, so this is my NAND, right? This is my AB bar, and then what I will do, I will write A, then B, okay, and okay, so I need more space here. I need more space. Sorry, right? So this will be A, this will be B, then I have A bar, then I have B bar, okay. Then what I will do, I will do OR of A bar plus B bar, okay. So I will write like this. This is 0 0 0 1 1 0, then 1 1, okay. So this will be 1 1 0 0. This will be 1 0 1 0, okay. And if I will OR it, 1 plus 1 is 1, right? So 1 0 is 1, then 0 1 is 1, and this is 0, right? This is exactly what I have, right? So this is famously called as what we call as De Morgan's, right? So this is how you can convert AND to OR, okay. And you can also write like this A plus B bar, right? You can write like this A bar dot B bar, okay. This is also the other uh, way, right? So this is you are converting from AND to OR. This is you are converting OR to AND. Is that clear?
So the fifth question, if we have to do it in POS,
Yes.
yes, sir. If we have to do it in, if we have to find product of some,
Yes. How will we find?
yes, sir.
Yeah.
Yeah.
Okay, so that's a good question. Anybody want to help me with this question? Uh, yeah, you can mute. You can mute. Anybody want to help me with this part? What I have to do now is I have to instead of summum product, I have to find product of sum, right? And I have the same literal, right? So instead of small m, I have capital M, right? Anyone?
That is y plus z
Y plus Z
dot
dot.
x plus y bar plus z bar,
This is
I think.
okay. Can you tell me how do I approach this question, right? So I have a Carnot map, right? And now I have X, Y, and Z, right? So this is 0, 1, then this is 0, 0, 0, 1, 1, 1, and 1, 0, right? How do I
Yeah.
approach?
Here the 0 refers the inverted value, that is, sorry, non-inverted, and 1 for inverter.
Okay.
So that is x and x bar.
Mhm.
And in top line, that is 0 refers non-inverted, right? So y bar, y plus z. Then the second term is y plus z bar, and third is y bar plus z bar, and fourth is y bar plus z. And just we are taking the zeros, that is 1 2 5 6 7 are min terms, so that is 1. So the remaining terms are 0 4, sorry, 0 3 4 are the max terms.
Okay.
So those are represented by 0.
Okay. So let me
So
just see 1 minute. So these are my max term 1, right?
yeah,
And
just we can keep it as it is 0 for not confusing us.
okay, I will just keep it 0. Then
0,
right,
and 3 is 0,
3 is 0. This one.
and then 4 is 0.
Then 4 is 0. Okay.
Yeah.
Okay.
Now we can combine these two, that is why we can combine the 0 and 4.
Okay, let me combine this. So this will be y bar plus z bar, right?
In this case, that is y plus z.
It will be y plus z,
It is just opposite to the min-term evolution.
right? And this
Yeah,
particular part,
and that is a single number group, that is x plus
x
y bar
plus y bar plus
plus z bar.
x.
Yeah. Yeah.
Anybody has any question? Please note that this is for this particular part only, right? So if this is my mean term, right, so this will be my max term. Okay, so let me explain how what he has said and how does it works. Okay, so wherever you have written 1, right, so those were your min term. Okay, so this was my min term. Okay, uh, the place which was not filled, those are my max term, right? So you can write 0, right? And for 0, the 0 actually represent 1, right? So it's not the complement one, it's the exact one, right? So in this particular case, and then you have to write into in the product of some form, right? So this will actually give you what we call it will give you, right? So the first term will be y instead of y bar, right? And the second term will be z, right? And it will be added. Okay, it will be like this. And similarly, here this is because it is 0, it will be x, right? And then here it will be y bar, right? And here it will be z bar, right? So this is y bar and this is my z bar. Okay, what you can try out in your home, instead of this says small m, if it was capital M, right? So all of these were your max term. Okay, what would be the answer? Okay, so this just you note down, just take a screenshot of this slide and just try it out. Okay, if all of these are my max term, what will be the answer? So I have 7 minutes left, and I want to go to the last question. Okay, and then I have, I think, one question to take. Uh, can anybody tell me the answer? Here I have something what we call as don't care. Okay, don't care. Can anybody tell me the importance of don't care, or what do you mean by don't care? When do you
It,
use don't care here?
it may be 0 or 1. We can consider whatever required.
Okay, that is fine, right? So that is how you proceed ahead. But why the concept of don't care exists, and how does it help us?
Something is whichever is not important, maybe in on condition or off condition, whatever. So just by the name, we can say it's don't care. We don't care about whether it is yes or no.
Okay, it is not important.
Yeah.
Anybody else want to answer this question? Don't care. See, I want to design a hardware, right, which has 4 inputs, A, B, C, and D. Okay, and if you have written something as don't care, it means that that particular pattern won't be coming in your whatever hardware you are designing, right? And that is the reason why you can write it as 1 or 0. It doesn't matter because that input pattern doesn't come, right? And it will help you to simplify the hardware. Okay, so because it is not coming, that is the reason why you can use those terms as don't care. Can anybody tell me what will be the answer of this particular? So you see, this is AB and this is CD. Okay, I want the answer from you.
Three quad group.
Sorry,
Three quad group.
I couldn't
Quad.
hear. Yeah, sorry. Can you repeat
Yes,
again? Hello. Hello.
my answer?
Can you repeat?
That's I think I have another person. Can I answer?
Yeah, you can answer. Yes.
A bar B bar
A bar B bar
plus A bar D bar
plus A bar D bar
plus B bar D bar.
plus B bar D bar. Anybody has a different answer? Anyone? Okay, let's see what is the answer. Okay, so if I see here, right, what I can do, I can combine this and this. Okay, and apart from that, I can also combine these four: 1, 2, 3, and 4. Right, I have only two combinations. Okay, so let's see what will be the answer for this combination. What is the common here? This will be my A bar. Okay, and what is common here? uh, this will be my D bar. Okay, that is correct. And for this combination, what will be the answer? Right, so you can see what is common here is can anybody tell me what will be the combination of these four?
That is D bar, D bar,
B bar,
D bar.
D bar, right? So only these two.
Sir, can you repeat how to take combination?
How to take combination? Right, so you can come
Yes.
yeah, you can combine this, like, right. So see, the basic concept of Carnot map actually comes from this particular aspect. You should know, right? So I hope you know this, right? Let me just repeat again for you, right? So it's like this: whenever there is something like A plus A bar that can be combined, okay, to form one. Okay, so if you see, if you want to combine these two, right, just you are combining, if you want to combine these two, what you are doing, right, so you are just writing C bar D bar, that is fine, right? But here you are eliminating one of the variables, and which variable it is? You whatever the common is, you write, right? So you write A bar, right? And you are eliminating the B plus B bar part. Okay, because B plus B bar will be 1, right? So that is the reason why you can eliminate, and your answer is C bar D bar here. Okay, so this is the basic concept of Carnot map, how the Carnot map works, right? And every combination in which you can represent or you can combine this kind of thing, uh, it can be combined, right? Now let me tell you what are the combination that can be combined, right? So these combinations can be combined. Okay, so you can have a square kind of structure. Okay, you can combine this 8. Okay, this 8 also you can combine, you can pair 8. Okay, apart from that, if you the extreme case, one of the extreme cases is this one. Okay, this 4 can be combined, right? Apart from that, you can also combine this, you can combine this, right? Please note, the Carnot map can be wrapped around, right? So because it is a gray coding. Okay, and that is the reason why we choose gray coding, such that there is only one bit difference, and you can combine this part with the this part, right? You can see if you want to combine these two, this variable is same, so D will remain the same, D bar will remain the same, and C can be combined C plus C bar, right? So it will be D bar. So that's how the Carnot map works. And once you know that, okay, these are the combination that can be combined, what you have to just see, what are the variable which are common, whatever variable is common, you just keep that, and whatever variable that is different, you remove it. Is that clear?
Yes, sir. So in the fifth question, we have found POS for max terms. If we have to find POS for min terms, then we have to consider the number of ones, is it?
POS for min term?
Yes, sir.
No, no, I didn't get your question. Can you repeat?
Sir, we have found out POS for max terms.
Correct.
That is, we have considered the zeros.
Yes.
If we have to find the POS for min terms, then we have to consider the number of ones, is it?
No, actually, the min term is actually associated with sum of products. It is not associated with product of sum, right? And when I talk about product of sum, you talk about max terms. So that term is actually associated. So that is nothing like you find min terms or you find product of sum for min terms. It's it's not like that.
Okay,
Okay,
sir.
right? So you have to eventually convert that into max terms, and then you find, if you want to find product of sum, and If you're going to other way around, you have to convert into min terms to find sum of product. That's how it is.
Okay, sir.
Okay. So yeah, we are done for
So I have
today.
a
Yeah.
doubt.
Yes.
Can I ask?
Yes, you can
Uh,
ask.
it's regarding the assignment question.
Uh-huh.
That is, I have came with the words single point. Single precision floating point binary,
Yes.
and another question having the word IEEE 754 single precision 320. Sorry, 32 bit. So
Yes.
is both are same or different?
Correct. Both are same actually. Right. So let me tell you what are the things are, and just in case you just remember. Okay. 1 minute. Just it can. Right. So there are various terms. Right. The first one is IEEE 754. Right. So this is the standard. Okay. This is the standard. Okay. So there are two precision which are generally available, right? And we go up to three precisions, third precision also. The first precision is single precision. Okay, single precision. Right. When I talk about single precision, it is 32 bit. Okay, single precision it means 32 bit. When you go to double precision, right, it is 64 bit, and you have quad precision, which goes up to 128 bit. Okay, in single precision representation, you have one sign bit, 8 exponent bit, and 23 mantissa bit. In double precision, you have one sign bit, 11 exponent bit, and how much is left? 50, 11, 52 mantissa bit.
52.
Right? So IEEE 754 is the standard. Please note, IEEE 754 is the standard, right? Which is the nomenclature of any standard, right? If you talk about Wi-Fi, it has the standard 802.1, right? So that's the standard. Okay. Then you have various type of representation in that, so single precision, double precision, depending upon whatever the requirement your system has. Okay, so if you want to represent very large number, you have to go to double precision, right? If you want to represent small number, you have to go to single precision. For your assignment, wherever it is represented as single precision, it means 32 bit. If it is represented IEEE 32 bit, it is again same thing. If it is represented IEEE second single precision, again it is the same thing only. Okay.
Sir, there is another question called the 14-bit value.
So
So for the
14-bit precision would have been taught in the class, I think. So that's not a standard precision, but for the assignment it has been created. So what you do, you might want to just see the lecture. There it has been shown what a 14-bit representation is.
okay, sir.
Okay.
Is
So
there any relationship between the exponent and the Mantasy numbers, or it's just standard for this kind of things?
sorry, can you repeat again?
So for the 30-bit precision, we are saying that the exponent having the 8 bits and the Mantasy had having the 23 bits.
Yes.
And similarly for 64, it's 1152.
Yes.
Is there any relation by calculating the value number 8 or 23 one?
No. There is no relation as such. So whoever has designed, right, they have decided, okay, I will take 8 bit, right, and then they have went to 11 bit. Okay. So please note something I want to discuss about the number system and representation, right? You know that, okay, one this sign bit represents sign, right? So that is absolutely clear. But what about the exponent and mantissa? What is the significance of this exponent and mantissa? Right? You might be doing the lectures and you might be solving the assignment, but can anybody tell me what is the importance or what does it represent? So exponent actually, anybody want to answer what it actually represents in a number system?
Probably it may be how many number of digits in the binary value like that.
Not really that. Other actually, exponent represent a dynamic range. What is the maximum and minimum number you can represent? Okay, so exponent decide that. So how much large a number can be, right? So and then the mantissa represent the accuracy of that number, right? So the more the decimal place you have, the more accurate your number is, right? you don't actually require so many decimal places. But in the extreme applications, like if you want to say go to space, right, so very precise calculation has to be done, right? At that point all this precision has been required. But suppose if I'm talking to you, you're seeing my video, right? These are error resilient application. Even if you don't provide so much bits, it will still work. Okay, so that's how the hardwares are designed. Some hardwares are designed in 16 bit, some are designed in 32 bit, right? If you go to a camera, it might be working in other precision. If you go to a GPU, right, it might be working in other precision. And there is one more hardware that is called tensor processing unit. In the recent scenario, if you go to that part or that hardware, it is working in different precision. Why? Because for different application you have different requirements. Okay, and for different application you will be using different number system, or using same number system but with different standards, like single precision, double precision. What we also have is what we call as half precision. Then people talk about 8-bit precision, right? This is some additional information I'm giving to you, but I hope this will be helpful in understanding the number system. So whenever you are understanding the number system, you just don't have to try to convert whatever number you have into IEEE 754 or like that. Rather, you should understand why this number system is important and what is the each of this term actually means. Okay.
Sir, can you please tell us how to convert a floating point number to a decimal number, if you can, if you have time?
Just a minute. I
Yes.
have to share. Okay, so let's see. Can you give me any example and I will.
Yes, sir.
It should not be for assignment. Okay.
Okay, sir. One second. So one one. Yeah, you can take a number, sir.
No. So what I will do, I will just reconvert whatever I have taught in the class, right? I think that will
Yes.
be best. Okay. So and you know the answer also, so you will trust me. Whatever I have done is correct. Okay. So this is the number. Okay. And what I have to do is I have to convert this into 14.25. Okay. Let's see how to do that. So the very first bit is the sign bit. So you know that, okay, it's a negative number, right? And then what you have is 10000, and yeah, how many zeros? 5 zeros, and again 10, right? 5678, right? This is your exponent, right? And this exponent represent which number? It is 130. Okay. So when you represent, what you represent is 2 to the power e minus 127. Okay, e minus 127, this is what you represent. And minus 1 to the power s, right, into 1 dot n. Okay, so from here you have to find out this particular part, e minus 127, right? So this will be minus 1, so minus 1 into 2 to the power, what we have is 3. Okay, then what do I have here? The number which I have is 1 point, this is the mantissa part. Okay, 11001. Okay, and then all are 0. So please note here it is 2 to the power 3. Okay, so I can go left 3 decimal places. Okay, or I can go right 3 decimal places. So what I can do is I can write like this: 1110.01, right? Just to remove this part, and again it is minus 1. Okay, so it is negative, right? Now you convert into binary, right? So this is what? This is 14, so minus 14, right? And this is 0 1. right? 0, 1 will be 0.25. Is that fine? Hello.
Yes, sir.
Right, so it's very simple, right? So you just convert this. The only part is to just find out this exponent value. You shift from that exponent value and you will get answer.
Sir, can you go to question number 6? I mean,
Question number which one? 6.
question number 6. 6 1.
1 minute. Question number 6. Okay, yeah.
Yes, sir. Sir, I have doubt that, I mean, you explained now that we have to combine. So we got three terms. Like, miss, the first one we combine, no? So we have a bar. Yeah, a bar. Here from CD we have CD bar. So how we took like a bar, D bar, means we merge it or what?
Okay, let me just hear the question again. Okay, 1 minute. Just let me remove it and you tell me
No,
what.
sir, I got it everything, but
Okay,
the things that you have
the
written over
conceptually you
here,
are
na,
saying.
to
Okay, okay.
combine.
So what you are saying
Yeah.
is,
So how to we run? I mean the last expression how we wrote that we are writing directly or we merge it like
no, no,
means
you
how
merge
to
it.
write down that combination.
Okay, you are talking about A bar D bar or B bar D bar. So I will explain with one example. A bar D bar, should I explain?
Yes, the yeah
Huh.
last answer how we write down from the table. I
Okay,
mean
okay. Yeah,
from
yeah, sure,
that
sure.
came up.
That I can
That,
help. Okay. So
mm,
you see, for all of these four terms, okay. If you see only A and B, right? Uh, you can write like this. Okay, you can write like this: is A bar B bar plus uh, plus what do you have? A bar B, then multiply it by, right? If you see these two terms, okay, this will be C bar D bar plus C D bar. Okay, so this is the actual expression what you have. Okay, so whenever the Carnot map represent, this is the expression you have, right? Now because we have understanding and we are so fast, we directly write it, right? So what you do, you combine these two, right? So A bar will be common, B plus B bar, it will remain A bar dot, then again D bar will be common, right? And C, it will be C plus C bar, you will write D bar, right? So that's how you get A bar D bar,
okay, sir. Okay, got
right?
it.
Yeah.
Yes.
I hope the session was useful for you guys. Okay.
Yes, sir. It's
Okay.
very helpful.
Okay. Then we will meet again next Tuesday, same time. Okay. I'll be
Okay,
uploading
sir.
this video in the YouTube. I hope NPTEL has shared the YouTube link. Have they shared? Hello.
No, sir, not it.
Okay, just give me. What I will do is, before that, what I will do is I will close the session. So thank you. And just 1 minute.